Good morning, children. Now, welcome back. In the previous video, we have been discussing about the structure of mitochondria and the formation of a molecule called ATP. And I have mentioned you what is the full form of ATP. Adenosine triphosphate. So, this is an energy phosphate which will be in this form. In the last phosphate bond, there will be the energy. In that last phosphate molecule, the energy will be supplied for the further functioning of the body. So, this is called as what? Energy currency. What is this called, ma? Energy currency. So, this is the form of ATP molecule which can be said as adenosine triphosphate. Adenosine triphosphate. So, whenever we need energy, we can get energy from this ATP molecule. And each ATP molecule, as I have mentioned you, it will carry 7.2 kilocalories of energy, or simply you can say it as 7,200 calories. Each ATP molecule can carry an amount of energy of how much, ma? 7.2 kilocalories or 7,200 calories of energy. 7,200 calories of energy. So, whenever we derive energy from this ATP molecule, it will be changed into ADP. So, when we draw energy from this ATP molecule, this ATP will be changed into ADP. I hope you understood the difference. This is ATP, adenosine triphosphate. 3 phosphate bonds will be present, in which energy will be present in the last phosphate bond. This is called energy bond. Now, whenever we draw energy from this ATP molecule, which is containing 7.2 kilocalories or 7,200 calories, it is changed into ADP, that is adenosine diphosphate. ATP will be transformed into ADP, that is nothing but adenosine diphosphate. In this way, energy will be supplied to our body in the form of ATP. And what is the powerhouse of the cell? Mitochondria. So, the organelle which is helping for cellular respiration is mitochondria, which is called the powerhouse of the cell. So, the powerhouse of the cell is mitochondria and the energy currency is ATP. Okay, and now basing on the availability of oxygen, this respiration is classified into 2 parts. Okay, so one is aerobic respiration, other one is anaerobic respiration. Before going to that, let me explain you what will happen in the process of respiration first. Okay, you all understood that each and every cell will receive oxygen now. That is called as cellular respiration. And surprisingly, few organisms can respire without the help of oxygen. What is the first step of respiration means? Now, first of all, you can take glucose here. Here I have mentioned that glucose is changed into pyruvate. Now, you all know, symbolically, we can mention this glucose as C6H12O6. The symbolic form of glucose is C6H12O6. Now, this C6 will be broken down. Now, in your photosynthesis you have studied. What is photosynthesis? Photo means light, synthesis means production. Photo means light, synthesis means production. So, production of food in the presence of light is called as photosynthesis. Now, this happens. This C6H12O6 will be broken down here into 3 carbon compound called pyruvate. What is this? Pyruvate. And in the previous class I have mentioned there are 2 types of respiration. How many types of respiration? 2 types of respiration. The first type is undergoing respiration with the help of oxygen, and the second type is undergoing respiration without the aid of oxygen. That means this is in the presence of oxygen and this is in the absence of oxygen. Okay. whatever it is, either aerobic or anaerobic, the common step for both the respirations is glycolysis. In your photosynthesis, you have studied photolysis. How many of you remembered or not? I couldn't understand. But whatever it is, there is a first step called photolysis in photosynthesis. Photo means light. Lysis means breakdown. They are breaking off a water molecule with the help of light. That is why it is called as what? Photolysis. Now, in the same way, you have a step called glycolysis. What is that? Glycolysis. In the respiration process, there is a peculiar step in both aerobic respiration and anaerobic respiration called glycolysis. Glycolysis. Glyco means glucose. Lysis means breakdown. Glyco means glucose. Lysis means breakdown. This 6 carbon compound called glucose. Now see, this is a chalk piece. This is a chalk piece. Now I am breaking this into 2 equal pieces. Okay? This is a small chalk piece now. This is also a small chalk piece. If we combine, this is a very long chalk. Now I am converting this into pieces. Now I have a chalk here. I have converted into chalk pieces. Like that, here also, this 6 carbon compound glucose is broken down. That is called as what? Glycolysis. Glucose means sugar. Glyco means glucose. Lysis means breakdown. So this is called glycolysis. What is that called? Glycolysis. So glycolysis means breaking down of a sugar molecule into which compound means pyruvate. So that is why in here I have mentioned you that is a 3 carbon compound. Pyruvate is a 3 carbon compound. This C6 will divide into 3 carbons this side, 3 carbons this side. This 3 carbon compound is called as what? Pyruvate. It is common for both aerobic respiration and anaerobic respiration. Now glucose is converted into pyruvate and it will give us energy. It will give us energy. And how many types of respiration I said? 2 types of respiration. One is aerobic respiration, other one is anaerobic respiration. Further I will tell you what are the differences between these two, but now just listen. What are the 2 types of respiration? Aerobic respiration and anaerobic respiration. In the first tab I have mentioned you absence or low amount of oxygen. That means there is no supply of adequate oxygen to this. In this type of respiration, there is no adequate supply of oxygen. So, in the absence of oxygen, we call it as what? Anaerobic respiration. I hope you are following me. Anaerobic respiration. Anaerobic respiration, and this is also called as fermentation. Fermentation. Okay? And next one is presence of oxygen. In the presence of oxygen, we can't expect our life to survive without the aid of oxygen. If there is an arrest of supply of oxygen to our bodies, within no minute we will die. Because we are undergoing which respiration? Aerobic respiration. Which respiration? Aerobic respiration. Now, in the aerobic respiration, presence of oxygen, and in the anaerobic respiration, absence of oxygen. You can find this type of anaerobic respiration in both bacteria and yeast and almost all unicellular organisms. All unicellular organisms, maximum, they will undergo which kind of respiration? Anaerobic respiration. Anaerobic respiration. Okay, and now when you come to bacteria, how it will respire means it will break down glucose and convert it into lactic acid and energy will be released. You got my point now? Glycolysis is common step for both. After that, the pyruvate will be converted into lactic acid and also energy will be released. So if lactic acid is released, it is undergone by bacteria. And if you take an example of yeast, which you have studied in your 8th class. In your 8th class, you have studied a process called fermentation. Fermentation of idli dosa products. Fermentation of downs, maida. For the preparation of cakes. For the preparation fermentation of bread. Okay, so in all this process we had a term called fermentation. Fermentation. Okay, so here what will be released means by breaking down of glucose, pyruvate will be formed, and from that pyruvate ethanol will come. Ethanol, and also CO2 will be released, and also energy will be released. Energy will be released. Okay, and good example here is yeast. Good example here is yeast. But when you go to anaerobic respiration, that means in the presence of oxygen. Good example is wheat, that is multicellular organisms. Okay, almost all the birds, almost all the plants, almost all the animals comes under multicellular sector. Okay, now as we are multicellular, we undergo which kind of respiration? Aerobic respiration. Right, now when you come to aerobic respiration, they will be releasing carbon dioxide, they will be releasing water, and they will be releasing energy. Once again go to this now, they will be releasing what? Carbon dioxide, they will be releasing water, they will be releasing energy. They will be releasing energy, and good example is plants and animals. Plants and animals. So now let us see what are the major differences between aerobic respiration and anaerobic respiration. Major differences between aerobic respiration and anaerobic respiration. This is a very important question for your public exams. In the examination point of view, you can surely expect 4-mark question from this point, that is aerobic respiration and anaerobic respiration. Try to differentiate between respiration undergoing in the presence of respiration or in the absence of respiration. It's one and the same. That means you have to differentiate between aerobic respiration and anaerobic respiration. Aerobic respiration and anaerobic respiration. Okay, and now let us start. Aerobic respiration means it is happened in the presence of oxygen. It is happened in the presence of oxygen. Please listen very carefully, ma. This is a very important question. So, aerobic respiration happens in the presence of oxygen. Anaerobic respiration happens in the absence of oxygen. In the absence of oxygen. Okay. So what is aerobic respiration? This respiration happens in the presence of oxygen. This happens in the absence of oxygen. And what will be released in the aerobic respiration means CO2 will be released. Water also will be released. What are the products of aerobic respiration? CO2 and water. What are the products? CO2 and water. But when you come to anaerobic respiration, CO2 and ethanol will be formed. If it is ethanol, it is yeast, and if it is lactic acid, it is bacteria. Okay? So, if it is ethanol, we call it as what? Fermentation. In bacteria, there will be release of what? Lactic acid. In yeast, there will be release of what? Ethanol. So, what are the products of anaerobic respiration means? Either CO2 and ethanol, or else CO2 and lactic acid. CO2 and lactic acid. Okay? And now, what are the steps involved in aerobic respiration means? For your higher classes, you will be reading about Krebs cycle, which is eliminated for your portion for the process now. Okay? But here, what are the 2 steps involved? Already I have mentioned about glycolysis. Glyco, glucose. Glyco means glucose. Lysis means breakdown. Lysis means breakdown. So the first step for both aerobic and anaerobic, you can see very clearly here. This is also glycolysis. In anaerobic respiration is also glycolysis. This is both common. Okay. Now see here. This is the first step of aerobic respiration, glycolysis, and the second step is Krebs cycle. Second step is what? Krebs cycle. Okay. And actually in your higher classes, when you go to degree levels like that, you will be learning a concept called electron transport chain. That also will be there. But for your syllables, it is not there, of course. Up to glycolysis only you have to study. These are the steps which you will be studying in your higher classes when you go to degree levels like that, intermediates like that, right? Now, so what are the 2 steps involved in aerobic respiration in glycolysis and Krebs cycle? Whereas when you come to anaerobic respiration, glycolysis and fermentation. Glycolysis energy will be released. 686 kilocalories of energy will be released. That is why we have mentioned here that it is high energy is released. High amounts of energy is released. When you take anaerobic respiration, low. Clearly, you can see here that is low amount of energy is released. Low energy is released. If you see in anaerobic respiration, each glucose molecule can give only 56 kilocalories of energy. So you got the difference. 686 is very high when compared to 56. So that is why I have mentioned you that aerobic respiration high energy is released. In anaerobic respiration low energy will be released. And you can take it granted that multicellular organisms can undergo aerobic respiration and almost all the unicellular organisms can undergo which respiration? Anaerobic respiration. So you can find this kind of respiration in multicellular organisms. Which organisms are? Multicellular organisms. When you come to anaerobic respiration, it will be seen in unicellular organisms. Unicellular organisms. And finally the equation goes like this. 6CO2 plus 6H2O. Clearly ma? 6CO2, 6H2O, 6H. What are the reactants means? C6H12O6. C6H12O6 plus 6O2. That means one glucose molecule, when it combines with 6 molecules of oxygen, it gives carbon dioxide, water, and already I have mentioned 686 kilocalories of energy. When you come to anaerobic respiration, C6H12O6, here I did not mention O2 because which kind of respiration? Anaerobic respiration. Anaerobic respiration. Okay, so directly we give 2C2H5OH plus 2CO2 plus only how much of energy? 56 kilocalories of energy. So by this we can understand that high amounts of energy is released in aerobic respiration and low amounts of energy in anaerobic respiration. Okay. So finally see here ma, it is happening in the presence of oxygen, in the absence of oxygen. The products are CO2 and water. Here the products are CO2 and ethanol in yeast and lactic acid in bacteria. Steps are glycolysis, Krebs cycle. Here the steps are glycolysis and fermentation. High energy is released, low energy is released. It occurs in which organisms? Multicellular organisms, and it occurs in unicellular organisms. So these are the differences between aerobic and anaerobic respiration. So for your safe zone, what you have to do is you have to be very thorough with this differences, because many a times frequently asked a question in the public examination. So go through these differences carefully and get ready for the next class. Meet you back. Have a nice day.